In the previous lecture, we talked about double slit diffraction. And in this short lecture, we're going to talk about a couple of different other types of diffraction that show up in different situations. If you had a lot of slits to your apparatus, it's called diffraction grating. And you get, let's take, instead of coherent light, let's put white light through here. You get some cool rainbow diffractions. And why does that happen? Well, remember our formula had to do with m lambda, right? And that lambda is wavelength. So all of these different colors have different wavelengths, right? So the points where they're going to have constructive interference is going to be different for different colors. And so here you have your indigo, and here your violet, and here your blue, and here your green. Each of those has different constructive interference spots, and so you end up with a rainbow diffraction. This is what happens when we have iridescence on butterfly wings, because they have the way that those wings are constructed basically has light go through a similar process to this, where you get little wavelets that are interfering with each other. And if you put monochromatic light through diffraction grating, it creates very nice, precise maxima. Now, of course, if we did different colors, right, the red might have a peak here, but like the blue might have a peak here, and the indigo might have a peak here, and that's why you'd get that. So these are useful for scientific analysis of waves, which is important in a lot of different fields. If we do a single slit diffraction, you actually get interference from the wave itself, which is, again, sort of crazy. And that has to do with the fact that the slit itself has some distance, right? And so you have a little wavelets emerging from here and here and here and here and here, and those are going to interfere with each other in different ways. Not surprisingly, it's less noticeable than with the diffraction grating. So you'll get a really strong center with oscillations off to either side of that. But you do see that in single slit diffraction. And then the last thing we want to talk about is thin film interference. This results because of the way light diffracts through a surface, right? So let's imagine that waves hitting, say, a bubble some are gonna bounce off the top of that surface, and some will bounce off the bottom surface. So we have incoming light. Some bounces off here. Some of the light goes over here and bounces off the bottom edge of the bubble and then comes back out. So this light has traveled a little bit farther than this light. If it's traveled half a wavelength farther, they're going to destructively interfere. If it's traveled a full wavelength farther, they're going to constructively interfere, and you're going to see that particular wavelength in a brighter way. So that's why you'd get different colors here. Because again, we can decide whether they're going to constructively interfere by our wavelength, but our wavelengths are different for different colors. So a bubble might have thicknesses that vary in very small ways throughout the bubble. And so in some parts of the bubble, you're going to get violet constructively interfering. In other parts, blue is going to constructively interfere. In other parts, red is going to constructively interfere. And that's why you get that cool rainbow effect in soap bubbles. You also see it in oil slicks, right? When someone's got some oil that's spilled in a puddle, that oil forms a very thin surface on the water, and you get the same thin film interference. So another cool instance of constructive and destructive interference with electromagnetic waves.